The next thing to talk about with these classes and the objects that we create from them. We note that what happens to the data fields follows from, first of all, the rule that the Java virtual machine, when it allocates space for an object from the heap, before anything happens to the object, those memory bytes are replaced with the 0 values, erasing the trace of whatever other objects may have existed in that memory at the time. So both the safety and security feature. Now this has a nice consequence that all the data fields, you can take it to the bank that they start their life out with the known 0 values. All the integers and decimal numbers are 0 and the Boolean fields are initially false. So this is now also necessary because the Java is intended to be 100% portable. So the same Java program, we should be able to run it in any environment, and it produces equivalent results in all. So this wouldn't be even true in the same environment if every time you run a Java program, the values of the objects fields essentially would start with the random values. This same guarantee is not in effect for local variables. You must explicitly initialize a local variable before you try to access its value. You usually initialize a variable immediately when you declare it, but it's acceptable, it's allowed to initialize a variable later as long as no execution path through the method is possible that tries to read the value of the variable before it has been initialized. Now, what if you want, as you often do, the fields to be initialized to some non-zero values? So you can write what is called the field initializer. That's just a fancy word meaning that when you make the field declaration, you just say like a int, like we say double CM, we would say CM equals 42. So immediately like a assign, not assign, but initialize, it's a different operator. So you can initialize the field value at the declaration, but you should do this only if the right hand side of that assignment initialization is something that is a compile time constant. Because if the right hand side is something that, for example, contains a method call, so something gets executed before the current object has even finished initializing, so then this can create unpredictable results. And if the initializations depend on values of other fields, you're creating an order dependency, although I think the compiler will catch that these days. So you should only initialize with the constant literals, avoid a headache. Now if you want to initialize with the value that you don't even know at the compile time, you don't even know at the runtime until the moment that the object is to be created. So now we need a special method for this purpose, constructor. So constructor in Java and all these object-oriented languages based on this kind of inheritance. So JavaScript based on a prototype object-oriented. So then all these words, constructor means a totally different thing in JavaScript. So just a word of warning. But in this more of a mainstream object-oriented approach based on inheritance, constructor is a method that you never call yourself. It always automatically called exactly once every time an object is created. So this is the kind of initializer. So Python classes, the magic method init does the job of the constructor. So in the constructor, you assign the fields to the values that you want. And let's take a look at the constructor of length to demonstrate us. So how do we know? Here is a method. What makes it a constructor? So syntactically denoted by a bit of an odd rule. Notice the absence of the return type, not even void. So if it had a return type, it would be void, but so the fact that the method has no return type at all. So that's the fact that makes it a constructor, combined with the fact that it is named the same as the class. including the capital letter. So this is now one exception to the rule that the method name starts with lowercase. Constructor has to be named exactly the same as the class. And so many times this is really annoying. Notice that it is not a syntax error. Just by habit to type the void in there. What's the error that was found? Okay, so now we so now we cannot create the object because this no longer has the but this would without that main method this would compile. So this would be a perfectly legal method. Notice that the rule for the lowercase name for methods is just an agreement. It is not enforced by the compile. But this is such a common, like just by habit type this. Remember when you're writing a constructor. Has no return type. And after that, so it's a perfectly ordinary method. Notice it can receive parameters. So now you can insist to create the length object. You can provide a double value. Now here we're providing an int value, but the widening conversion from int to double happens automatically. So that one's fine. So if you don't define any constructors, so that it's possible to create an object, the compiler silently writes you a do-nothing default constructor that takes no parameters and then has an empty body. But at least now it's possible to create an object, whereas if you write the constructor, now the default constructor is no longer synthesized. So if you just try to create the length object without, notice it already flagging it as an error, requires a double. Although you can do method overloading, so you can write multiple constructors as long as the parameter lists are sufficiently different. It's not enough for the names to be different. As long if you look at the types, then the parameter lists ought to be different. Now when defining your own data type, so this is the one method that always is good to define right away. So this method is special in Java. So this is produces the human readable description of the particular object. So this is called by the virtual machine. Of course you can call it yourself. There's no magic in this method that return based on the current data fields. So this.cm, so here I have this here explicitly. Notice the string concatenation of different kind of things. So whatever string this method returns by definition is the string representation of that object.